We have a good mix of different cohorts here. It's nice to see.
All right, well, I guess I can probably start, but I'll give a quick little introduction. So, hello, everybody. Thank you for joining us. I think Jake and I are both a little surprised, but also really excited to see just this many people joining us today. We really just decided to host this for, I guess, our fun and also because I wanted to learn and because I figured so many other people would want to learn as well. So, Jake very kindly took on the challenge to host this event and to teach us all. So a big thank you to you, Jake. And so this is the first time we do something like this, so please bear with us for whatever may happen. And I'm thinking in terms of questions, Jake, maybe you'll be taking a few times here and there to stop and check in for questions, or I'll let you host it from this point on. But I'm trying to enable a chat function. I don't know if and how that'll happen, but I'm I'll back out from now on. Have fun, guys.
Okay. Yeah. In regards to questions, if anyone has any, maybe since we're starting to get about 40 people now, just use the raise hand. Try and as I go along and then stop as yeah, as Brea said, we're excited to sort of get this going. When she first came to me with the idea, I think we were both sort of expecting maybe 15, 20 people max. So, it's great to see just as many people here as a mandatory lecture, which is great. For those of you who don't know me, my name is Jake, and I am currently finishing up the business analytics program here at Ivy. One thing before we get into this that I do want to stress is I'm I'm not going to claim to be a master at Excel. Rather, it's something that I use frequently, and I feel like I have a good understanding of some of the ways that you can work with it and some of the things that you can do with it. The original idea behind this event was that it would be somewhat of a trial run, where if there's sufficient interest, we might look to sort of bring in a bit more of an experienced person, maybe that's a professor or someone from industry. That's still to be decided, but just sort of keep that in mind. So, I might not be able to answer super technical questions, but I'll at least take you through what I have. Again, before we start, just a couple things here. My internet can be a little bit questionable at times, so if I cut out, please bear with me. If you miss something, if I sort of glitch out, you need me to repeat something, please let me know. Additionally, if you want to dip at any time, you've got other stuff going on, or if you're like you're not getting a whole lot from this, I totally get it. Please go ahead. We're all busy. You're not going to hurt my feelings. Secondly, or maybe that's third, I do have a multiple monitor setup. So if you see me sort of looking around, I'm not paying attention to you. I've got a couple of screens. So the last thing here, like I mentioned, we have what looks like a pretty good mix from different cohorts and different streams. So it is somewhat difficult to strike a balance in terms of what is really introductory. For this session, I'm going to assume a relatively preliminary understanding of what Excel is. Maybe you've used it to store data before, or you've gone through different spreadsheets. So I'm not going to cover what the concept of a cell is or how to enter data. You can go to YouTube and find really, really great videos that sort of go through some of those baseline topics much better than I could. Rather, instead, where I think we can sort of introduce more value into this is by walking through a project step by step, from sort of data and data management to outcome and analysis. And in the process, what we're going to do is we're going to sort of touch on different topics such as I mentioned, data management, functions, conditional logic statements, some formatting, and a little bit of random sampling and scenario analysis. Hopefully in a way that I think is relatively straightforward, but as I said, if you have questions, please let me know. I probably will gloss over a little bit of the stats side. I don't have an expectation that everyone cares about stats, but we're going to. Okay, so let's get started with this. With the US presidential election about 10 days out, I figured it'd be fun to have our project here to be building a little bit of a presidential prediction. It's not super difficult to do a quick and simple one here in Excel, and what you'll see is the results are pretty close to some of the professional models where people spend months developing, such as 538 or The Economist, and a few of these others. If you've been following the news, you'll probably have seen that Biden is leading in the polls. But if you remember back to 2016, so was Hillary Clinton, right? So what we're going to do is build a model that, one, sort of shows what the expected outcome is, maybe the average expected outcome, and two, find a way to create some sort of probability that either candidate wins. Yes, maybe Biden's leading the polls now, but what's the chance, what's the probability that despite that lead, Trump still wins, right? What we are going to do is we're going to make quite a few strong simplifying assumptions here, but as I said, you probably won't find that they make a huge difference. Yeah, I see a question here from Hannah.
Hi, so my friend joined another Zoom. I just wanted to let you know there's two different links. I don't know where he found it, but like the one in details on Facebook gets us here. And there's like a group of people in another Zoom that like somehow got posted in error. I just wanted to let you know there's like some people missing.
Can you
Yo, I sent the link to Arch right now, and Arch is sending it to everyone.
Okay,
so
thank you.
Good. Yeah.
I think
don't know where they
adjusted
found
both. Okay, I'll go check the Facebook just to make sure, but good to know.
Yeah, thank you for pointing that out. Okay, so I posted in the Facebook group a data file. So if you'd like to follow along, you're more than welcome to. It'll be the same data file that I'm using, and we can build it all in the Excel file that's posted there. So what I'm going to do is I'm going to start sharing my screen, so you'll be able to see what this data file is. I assume everyone's able to see that? Yeah, okay, cool. So what you'll see is we've got two different tabs here. The one on the left is a list of a ton of different polls as of last night that are compiled by The Economist. They've got the state that it was issued in, some details about the poll itself, and then some of these top line numbers for both Biden, Trump, and a few other numbers. On the second tab is what are called electoral college votes. So the way that the president is elected is each state has its own election, and the winner of that state election gets assigned a certain number of electoral college votes. So if you win, Arizona, for example, you get 6 electoral college votes, right? And so out of a total of 538, the candidate who crosses the majority of those, so it reaches at least 270 electoral college votes, wins. And so in that sense, we're going to be looking primarily, only at state polls. National polls are good in the sense that they give us a good sense of how the national environment is doing, but that doesn't necessarily translate to the state level. So what you'll see in these polls here is under state where there are 2 dashes there, that refers to a national poll. So we're going to be focused on just the ones that have a state attached. So first thing that we're going to want to do is try and standardize this data in some sense. What you'll see, all of these polls have measures for Biden support, Trump support, but some of them also include others. Maybe that's a third-party candidate or write-in candidates. And there's also a column for undecided. To make all of these polls consistent with one another, we're going to create an adjustment so that we only look at the people considering a major party. So the first thing that we're going to want to do is for each of these polls, say, okay, how many people are planning to vote for a major party? So we're going to go total major. And for each of these, we're going to use a function. So a function in Excel is something that's called upon, you go into a cell, hit enter, and you can write some sort of expression. For example, that could be 5 plus 6, right? And then it'll run that expression, it'll run that formula and give you an output. What we can do is, for each of those inputs, we can use other cells. So in this case, we can say, okay, how many people plan to vote for Biden? And how many people plan to vote for Trump? And so that'll say, for this one poll, about 92% plan on voting for a major candidate. What we can do is we can apply this to each row in the data set. These are relative inputs. So what you'll see is if we copy this cell to the row below, it'll still only take the values that's in that row, which is nice. It makes it easy. So what we can do is we can drag this formula all the way down, and you'll see the relative values stay the same, right? It's all within the same row. One of the easy ways that we can sort of match this to everything is if it's in a data set like this, Excel will recognize this, and we can just double click on the square in the bottom right here, and you'll see it'll run that for all of our polls here. It just makes it a little bit bigger. Okay. So now we're going to create some adjusted columns for both Biden and Trump relative to what we just calculated. So we're going to say that adjusted Biden number will be the amount of support for Biden divided by the amount of support for a total major party. So in that sense, it would give us about 52% of people who plan to vote for major party. To make this consistent with some of the other values here, we can just multiply it by 100, and the multiplication in Excel is this little star. Okay. And so we can do a similar thing and find out all of this. We'll do a similar thing for Trump as well. Create an adjusted column for his. So again, we'll do the amount for Trump divided by the total for a major party. Okay, so now we have all of these polls in a similar format, and so we can sort of aggregate them and analyze them a little bit easier. So now we can say, okay, we've got these lists of polls. Let's try and understand our data set a little bit more. We probably don't have polls for every single state, but let's see how many states we do have polls for. So let's create another tab, just with a little plus in the bottom here, and we'll call it state check. So what we want to do with considering what states we have data for, if we have data for a state, that state will show up somewhere here in the state column. So what we can do is we're just going to run our analysis on just this column, just this state. So we're going to copy this column. When you click these tabs up top, it selects the whole column all the way down, even beyond the data that we have. So if you scroll all the way to the bottom, you'll see it continues to for the whole column for two. But we know that there's no more data beyond this. So we can copy full column, go over to state check, hit the first cell, and paste it in there. So now we have essentially a list of all the different states that are included in our set. We can get rid of state here because that's just a column header. Okay. Now what we want to do is we want to identify the unique values for each of these states. Okay. So we want to get rid of all duplicates. And if we do that, then we'll just have a list of the states we have to. Okay, how are we going to do that? First thing we're going to do is we're going to organize all of these states. And an easy way to do that is we just highlight the column, go into data, and hit sort. So this will categorize, it'll move the cells around and categorize them all in alphabetical order. So you see all of Florida polls are grouped together, and Georgia, etc. This makes it easy to create what we call a flag for if one of these values is a duplicate within our list or not. And the way that we're going to do that is we're going to say we can measure that if this cell is the same as the one above, then it's considered a duplicate, right? And we'll assign it a value if that is true, and another value if it's false. So what we can do is we can use sort of a logic statement that's built into the cell. So it's the same as the functions before. We hit enter. And what we're going to use is one called if. So we'll type in if. And you can see as you start typing, all of the built-in Excel functions show up. And so it gives you a nice list if you're looking for one, you know what it starts with, but you don't know exactly what it's called, and you can just sort of start typing on the screen. We're going to use if, which, as you can see from the description here, checks whether a condition is met. It will return one value of true, one value of false, just like I was describing with the flag. Once you click on that function, it'll tell you how it wants to accept information into that function. So it'll say, first, what is the test that we're trying to check? I outlined it before. We're going to say, if this cell is equal to the one right above it, then it is a duplicate. And if it is a duplicate, we're going to say the value of true, it's going to be 1. So this guy is going to be equal to 1 if it's a duplicate. If not, it's going to be equal to 0. So we did the same thing for all of this down here. And what we'll find is the first instance of each state within our list will be 0. And that is the first unique value, right? It's not equal to 1. But everything else is equal to 1. They have duplicate values. So what we can do, what makes it really easy, is we can then sort on this column and then just get rid of all the ones that have 1 as the value. And we'll be left with all the 0 columns, i.e. all of the unique values within the list. One of the problems that we'll face, though, is if we rearrange these columns now, based on this formula, the values above and below won't necessarily be the same. And so that will change the values that we're getting here. Instead, what we want is we wanted essentially what's called hard-coded values into each of these cells. We know what the output is. We can look at and say, okay, this cell has a 1 associated with it. But when we go into where that 1 is coming from, it's coming from this formula. We want it to get to the point where this will just show 1. And it's really quite easy to do. What we can do is we can highlight all of these values. And when you go to paste it back in, there are a couple different paste options. So if you paste normally, it'll just paste the formula. So that doesn't necessarily happen. Additionally, you can hit paste formulas if that's what you're trying to do. What we're trying to do is we only want the values that come from these formulas. So what we'll see is once I hit paste values, if we go into one of these cells, it's now equal to 1. So it's no longer coming from the formula, but it's essentially hard-coded as a specific value. So now if we sort all of these values won't change. So what we can do is highlight both columns, go back into data. Since we have 2 columns now, we'll hit the double column or multiple column sort function. And we'll sort it on column B, which is where our flag is. We can smallest to largest. And now it'll show us all of the 0 values, so all of the unique values, followed by all of the duplicate values. So we can just highlight all of the duplicate values. And hit now get rid of it. So now this is our list of all the states that we have polling data for. You see it only equals 44. And if we were capturing every voting block, we should have 51, 1 for each state, along with the District of Columbia, which isn't a state, but still gets electoral college votes, and so it behaves like a state within this context. So we're missing a few states. The good news is the states that we're missing data for tend not to be polled very often because it's pretty clear on who the winner is going to be. So in here, for example, we don't have any polls for Nebraska. Nebraska is almost certainly going to vote Republican. So in that sense, even though we're missing the data, we're not really missing the insight from the data because we can say with almost 100% certainty that it will go certain way. Okay. So now that we know all the states we have data for, Let's do one other summary statistics and say how many polls do we have for each state. So we're going to start turning this into a data frame. So we're going to start the column above as a header. So we give this a state header, and this is going to be number of polls. What we're going to use here is another built-in function called count. So let's say that we have a list of a couple of pieces of data. We want to say how many pieces of data do we have here. We can use count, and we'll give it a range, and it'll tell us how many pieces of data we have. We've got 4 ones. Notice that this cell is empty, so it's not counted. If we put a 0 in there because maybe it is supposed to be an observation and just the value is 0, we put that in. To find the number of polls, we'll do something very similar, but we're going to expand it a little bit further. We're going to say, look at this data set of polls. Count a poll if the state is equal to the one that we're looking for. So it just adds a condition into that count. So the formula that we use for that is count if. Another popular formula that works in a condition. So what we're going to do is we're going to give it a range of values that it'll look at, and then we're going to give it the logical test, the criteria. So in this instance, we've got count if. We want to give it the range. We're going to look at this column, the state column. I'm not sure how the shortcuts translate into Mac, so if some of you are using Mac, you might need to sort of go the long route and highlight everything as is. At least if you're on Windows, you can hit Control-Shift, hold those down, and hit the bottom arrow, and it'll highlight all of those rows within the column. So this gives us an array of values. So this is a whole column. Okay. Now we want to say the criteria. So we can go back to state check. And so for each of these values, we're going to say, okay, is the state equal to the state right next to it? So we're going to say, okay, so first of all, if we just say equals this, it'll get angry with us. It'll give us this pop-up error message. Sometimes when you're trying to say equals to or greater than or equal to in some of these conditions, you have to use a special syntax where the equal sign has to go in quotation marks. And then in between that, you have to use the numbers. It's kind of strange. Every time I run into issues, I still have to Google what the proper syntax is. So if you're using these methods and you run into a similar issue, I would recommend just going to Google and trying to remind yourself what this syntax is. But it's the comparative sign in quotation marks, along with an ampersand. Okay, so now we can run this, and it'll say from all the polls we have, we've got 7 from Alaska. If we drag this down, as we have for the other 4 ones, you'll see it's very similar, but it takes the relative value, just like the other times. And what we don't want that to do is shift the range in which we consider for our polls. So what will happen is you can see here the range that we gave for our polls was A2 to A1398. Once we move down, then this shifts as well. So it'll exclude the top poll in the row and include an empty cell underneath. We don't want that to happen. So what we can do is we can have it be fixed in the same location by adding a $sign in between the letter and the numbers. And another way that we can do this is just go into the variable, the letter and the number value there, and hit F4, and it should automatically do it. But you can do it. So now what you see, okay, there we go. So now as you drag this down, you see it references the same settings. This variable still moves because we didn't lock it down, but the range stays locked down. So we can apply that to each state that we're looking at. So what you'll see is the states that tend to be closer, tend to be more swing states, have a lot of polling. Arizona, Florida, Michigan, they tend to have a lot more polling, whereas ones that aren't expected to be particularly focused, like Alabama or Delaware, don't have it. Okay. Now what we can start getting into is trying to look at the averages for all of these polls. So far, this hasn't told us anything about how a candidate is doing in each of these states. So what we're going to do is let's copy this EC tab. You can do that by right-clicking, move a copy, move again, move a copy. That'll create a copy of the exact same tab that we can then sort of manipulate as we see it. We'll say this will be our first analysis. Okay, and so what we're going to want to do is for each of these states, on average, how poll going is. So what we're going to do is, if you look at these polls, there are two values that we can average across. We can use Biden or we can use Trump. I'm just going to go with Biden since this one here. So we're going to say sample or simple. To do this, we're going to do something very similar to the countif, but in this instance, the function that we're using is average. So you'll see average if. What it wants from us is a range that will check against the criteria, as in, is it the state that we're looking for? It wants the criteria, and then it wants a corresponding range to take the average from. So in this case, the range that we'll look at is the same as before, the polls, because that's what we're doing, the conditional check. Again, we'll highlight all of these polls and hard code those values. We'll say the criteria, is it equal to the state that we're looking at? Again, in the quotation marks, equals and state. And then the range that we want to look on is Biden's adjusted average, which we calculated here. Excel is pretty good knowing that this is a data set, and so it'll align the rows. And so if this is equal to North Carolina, then it'll include this in the average from North Carolina. But if, since this one's for Montana, it won't. Okay. So we're going to do the same thing. And again, sort of lock those values. There we go. So for all of the Alabama polls, Biden on average would be polling 42% relative to, which is certainly below the 50% that we would be expecting if he was leading the state. So in this, we would infer that Donald Trump is leading the state. Maybe not a huge surprise, but something that we can sort of quantitatively look at and see. So we'll do that for each of these polls. And what you'll see here is, for some of these, we have a divide by zero error. When it's running an average calculation, it takes the sum of all values and it divides by the number of values. For Arkansas, we don't have any polls. And so the sum of Biden's adjusted average would be 0, divided by the number of polls, which is 0. You can't divide by 0, and so it spits out this number. It's sort of uncomfortable. Like I said earlier, these are states that we essentially know the outcome. So we're going to hard code values in a way that is consistent with how we're thinking about these elections in each state. So with Arkansas, we know we essentially know that this is going to be a state that Donald Trump is going to be in. So for all intents and purposes, we can say Biden's average there is 0. It's not 0, it's probably closer to 30 or 40%. But from looking at outcomes, that's no different than if it was also. For DC, we know that Democrats are going to win that. I think the expectation is they're going to win by about 80 points, which is very substantial. So we're going to hard code that in as well. And we'll do the same for some of these other states as well. Illinois will be Democrat, Nebraska will be Republican, Rhode Island, Democrat, South Dakota, Republican, Wyoming, Republican. Okay. So now we've got a bunch of numbers. These are our polling averages for each state. It's kind of hard to see a list of numbers, so maybe let's format this to make it look a little bit more interesting and a bit easier to see. So what we can do is we can do a conditional, which takes the value that's in each cell, and based on a set of rules, we'll apply formatting for that set. So if we go into home, we can go into conditional formatting, and we'll add a rule. So in this instance, if the value is above 50, then that indicates our estimation of Biden's support is above 50% for those planning to vote for a major candidate. In that case, he is leading the state. So if he's greater than 50, we're going to just fill the cell with a light blue being the Democrat runner. Similarly, let's add another rule on top of that, where if it is less than 50, then the opposite is true. Trump would be in that state, so we'll get a red color for the Republicans. So in that sense, it makes it a little bit easier to see, okay, what states are leaning this way. And what we can do is now sort of create a point estimate where we can say, okay, based on the averages for each state, how do we expect them to go? So what we're going to do is we're going to add in a new column saying Biden lead. And in this column, we're going to use what's called an indicator variable, or a binary variable, or some people call it a dummy variable, which essentially means if it's 1, then it is true. If it is 0, then it is false. So in this case, what we're going to do is we're going to use that if statement again. We're going to say if this value is greater than 50, then he is leading, and we will give him the value of 1. If not, the value of false will be 0. And we can apply that to each state. So now we've got essentially what the conditional formatting is telling us, but in a numeric representation that we'll be able to use. If we want to apply the same formatting to those columns, we can copy these. And you saw before I copied in a special paste option. You can also copy in format. But the issue here is these are between 0 and 1, whereas here we're considering between 0 and 100. So our condition of 50 won't apply, so this will consider all of these less than 50. I see a question from Ryan.
Yeah, super simple, Jake. Sorry, I just missed which condition you put on the simple average column. I got everything else though. Was the condition just if it's below 50, then make it red? Was that it?
Yeah, so I put 2 conditions on there because you can stack rules on top of each other. So the first rule is if it's greater than 50, then we're going to color the cell blue. And the second one was if it's less than 50, then we're going to color it red.
Gotcha. Yeah, sorry, I just missed that. Thanks, Jake.
Yeah, for sure. Cindy?
Hey, yeah, I had a couple of students asking me, since this is being recorded, if it was going to be posted anywhere afterwards for people who aren't able to
Yeah,
make
for
it.
sure. So I'll do my best to try to crunch it down, and I might just end up sharing some form of file, either by email or something like that, depending on the size of the file, but we'll try our best to share it with you guys no matter what.
Okay, perfect. Thank you.
And Crystal.
Hi, Jake. Okay, wait, I just missed why. So my Excel sheet still has the divided by 0 error. So why did we make some 100 and some 0?
Okay, so when we get that divided by 0 error, essentially what that's telling us is there are no instances where, you know, like you would see that DC would have a divided by 0 error. So there are no instances where we have polls for Washington, DC. And so it's trying to divide by 0, and it's not letting what we know from sort of background information is these states that don't have any polling associated with them are almost certainly going to vote one way or another with 99.99% confidence in some sense. So in that sense, what we did is we just hard-coded values in. So what you see is the percentage values are coming from a formula, or for ones that we didn't have the data from. We can use just sort of our background knowledge and fill in data that's sort of consistent with what we want to see. Does that make sense?
Oh, okay, yeah. Okay, perfect. Thank you. I was just
Yeah,
confused.
yeah.
Thank you.
Sure, yeah, no problem. Okay, so now we've got a column where we're representing the lead if Biden has the lead. If it's the case that Biden wins the state, then he gets any of the electoral college votes associated with that state. If not, then he gets no electoral college votes associated with that state. There are a couple small states that do things a little bit differently. We're going to gloss over that for now, just to make things a little bit easier. So what we're going to say is expected Biden DC votes. And again, we're going to do a conditional value. So if he is winning the state, or if he's leading the state, maybe use this column. If that is equal to 1, then he's going to get those electoral college votes. So you can use that as the value of truth. If not, then the state or the votes he gets from that state will be 0. So in that case, he's not leading in Alabama, so we don't expect him to get those electoral college votes. If we assign this for these, he is leading in Arizona, so we would expect him to win those votes. And so what we can do now at this point is get some top line takeaway as to where we expect the outcome to be based on these polling methods. So what we can say is, let's create a little panel to sort of analyze this a little bit more. So we'll say total states equals to, we'll do the count, so we can count all of these states. If we're dealing with only, or if we're dealing with text values, so in this case, the state isn't a number, it's a couple of letters, we'll want to use count A. It just looks at whether the cell is empty or not whether it's a number. So we count A, we'll give it this column, and it'll count, okay, 51 states, 50 including Washington, DC. Let's look at the states by leading. Since we have the indicator column here, if he's winning states 1, so all we need to do is sum up these values. And states is leading. We'll just sort of be the reciprocal. So if there are 51 areas that can win, Biden's winning 28, then we know that the difference will be the number that Trump is leading. Okay, great. So Biden is leading 28 states as compared to 23 for President Trump. But again, each state has a different number of electoral college votes associated with it. So that might not mean anything. So let's calculate out the number of electoral college states associated with each of these. So we can say total EC votes, which is 538, or if you sum up this whole column, you get 538. We can say Biden EC votes. And since we already created a column for that, we can do a similar thing where we just sum that column. If he isn't leaving a state, then the expected votes from that state will be 0. And then the difference will be so again, it's just sort of a different. Okay, so what this tells us is based on the polling averages for all of the polls that we have, for all the states that we have, we expect on average Biden to be winning 350 electoral college votes compared to Trump winning 188 electoral college votes. So this is another way that we can sort of look at these this data and say, yes, Biden is in the lead, right? Which is certainly interesting. And what I'll show you here is it's not terribly far off from some professional pollsters. So if we look at 538, for example, here, I took this morning, they have on average Biden winning 345 electoral college votes versus 193 for President Trump. It's only a difference of 5 votes either way. So when you're dealing with a total set of 538 votes, 5 either way is not too big of a difference. And so on a single point estimate, this does a pretty good job at sort of matching some of these other professional pollsters, which I think is quite interesting. We whip this up in 40 minutes versus months putting these on. That's great. One way that we can expand on this further is we can look at what we've done and say, let's use Georgia, for example. Based on the averages that we calculated here, we say Biden is leading Georgia by 0.05 percentage points, which is really, really quite small. Polls are pretty good, especially used in aggregate, but they can still be off by 4 to 5 points. On average, in the past 20 years, presidential polls in the last few weeks have been off by about 4 percentage points. In 2016, polls are off by about 4.8 percentage points. So there is a bit of a range in which the true outcome can lie that's different from some of these values. So if we look at Georgia, if we were overestimating the true outcome by even 0.1%, then it could easily flip to Trump. And so what we want to say is maybe this is a bit more of a coin toss, maybe a bit more of 50-50. And so instead of assuming that Biden will win because he is technically ahead in the average, let's sort of look at a range of possibilities. And so we're going to move into what's called simulation analysis. So what we're going to want to do, let's duplicate this tab because we're going to sort of be building off of this this base going forward. So again, we'll say move and copy. Copy and we'll say second analysis. Okay. Now what we can do is we just get rid of those. So again, we're back to just the calculated simple average. If we know it's true that the true outcome can lie within a range, what we're going to do is we're going to randomly pick a number that's within that range. And ultimately what we're going to do is we're going to run that about 1,000 times to sort of generate the full, I say full, but the wide range of possibilities that could happen. And then what we'll do is we'll sort of analyze them. So one way that we can do this is just say, okay, if polls are off by an average of 4 points, you know, in Alabama, maybe the true value lies somewhere between 38 percentage points for Biden up to 46 for Biden. That's one way that we can do it. And the built-in functions from Excel are generally pretty good and convenient for generating these random numbers. The first sort of main popular one that we have is just random. And what you see here is it'll give you some random number between 0 and 1. And each of these numbers between 0 and 1 have an equal probability of being chosen. So you'll see here it was 0.79. We run again, 0.74. We run again, 0.14. We can keep doing that. We can do it many times. And what we can do is we can refresh these cells and give them values each time. So if you go into a cell, click on the formula bar and hit enter, you'll see it recalculates. Another thing you can do is, at least on Windows, you can hit F9 and it'll just auto update each of these cells. So that's what RAND does. It's useful for generating probabilities or really anything within the context of 0 to 1 on sort of more continuous side of things. Another good feature is the RAND between function, and you give it a lower bound and an upper bound, and it'll select some random number within those. So we can do 10 and 20, and so it'll give you a random number between those. So in one of our business analytics class, this is how our professor chose who would be presenting the case in front of the class. We were all assigned a number, and he would go into the cell up on the board, say RAND between student number 1 and student number 70, and he would go, okay, 1, 2, 3. Student number 31, you're presenting today. So for all of our cohort of business analytics students, RAND between has a very personal connection, and it still sort of gives me a little bit of a flashback. Okay, so those are some of the built-in random sampling features in Excel. Some ways that you can use this beyond polling is maybe you have data on a range of customers coming to your restaurant for each hour, and maybe you want to model out capacity in different scenarios. Maybe you want to use the randomized feature here to sort of explore what capacity might look like in a whole bunch of random scenarios. Maybe you're given estimates as to a bunch of different financial ratios and earnings for a company, and you want to explore random combinations when you're trying to estimate the value of security or something to that extent. There are a lot of features here that you'll be able to find sort of beyond stats and beyond polling. But again, this is sort of what we're using for this situation. Okay, through a lot of that. Let's bring it back to what we're doing here. We could say that the true value lies within this range, but we also want to say, well, I think this simple average does a pretty good job of where we expect it's going to be, but let's just allow for a larger range of scenarios. So we want values that tend to be closer to this average compared to, could be anywhere within that range. And so what we're going to use is what's called a normal distribution. And I'm going to sort of gloss over some of the stats here, but essentially that's what it does is it gives you a higher probability of getting a random variable sort of in the middle of what you're looking at compared to before. So just using this chart, on the right here, the uniform distribution is what the RAND function did, is it gave you some random number between 0 and 1, all with the same likelihood. With the normal, it just says the likelihood of getting a value closer to the middle is a lot higher, and as you get further away, the probability of getting that number decreases. That's essentially what it is. So what we're going to use here, we'll say this will be a sample. We are going to use what's called the norm in function. norm.in. And again, I'm going to sort of gloss over some of the stats here, but to take a random sample from that, when it asks for a probability, we're going to use the random function. So if you want to take a random sample from a normal distribution, if you ever find something useful, this is what you can do. So sort of the nested function runs there. Try not to get hung up on the sort of background meaning behind all of this, but this is sort of what we use. We want to describe the distribution by giving it an average value, which in this case would be our simple average. And then a measure of how wide we want the range of possibilities to be. In this case, let's put 8 because I ran a few calculations before we began, and that leads to a average polling error of about 6 points, which is a little bit more than 2016, but we could also look at this and say, okay, well, it's kind of a strange year. A lot of states are changing the focus of their elections. There's a much higher focus on mail-in ballots and early voting. And so we don't necessarily know how that'll fit traditional election methods. So let's give it a little bit more uncertainty to sort of account for that. So what you'll see is this creates just some random sample from the draw. And as we sort of refresh the page, you'll see really what it should be doing is trending on average will be around the sample average, but it could be quite a bit higher, could be quite a bit lower. But on average, it'll sort of be around the same. And we can do this for each of these states. So in this case, this is what we would consider a random sample for each state. We can copy over the formatting to make it look a little bit easier. There we go. And so if it's blue, then that means in our sample, Biden is going to be blue. I see a question here from, it's not giving me a name, but.
Oh, yeah, one. I'm just wondering, why do you use 8 in the normal inverse function?
Sure. So in some sense, I'm just giving you this number. If we were trying to build a really good model and a really, really robust model, we would spend a lot of time trying to figure out what we should put in here. I'm just giving you this number because if we use this, what we'll find is it'll make the average polling error similar to what we've seen in the past, just maybe a little bit higher given additional uncertainty.
I
That's
see.
really
So it's usually good to decide 8 if we have no clue.
I would say 8 just tends to work in this example. It's not true that it'll always be 8. So in that sense, you might need to be, this is where it sort of becomes a little bit more art than science, because you would need to sort of go through a process of trying to figure out what number you should have there that will fit the data that you want, that sort of matches what you're looking at. In this instance, I wouldn't get too hung up over this 8. This is just me telling you put 8 here, and it will sort of match what it is we're trying to do.
Got it. Thanks.
Yeah. Sorry if that's not super clear, but the focus here is more the process as to what we're doing, as opposed to what parameters we're putting in what data we're seeing. So this is just me telling you, just put 8 there for right now, and we'll sort of see. Okay. So here is essentially one scenario. This is one potential outcome because there's a random sample for each of these states. So let's do a similar thing and build a panel as we did before to sort of measure the results from this sample. So in this state sense, still got 51 states, still same number. So we'll count. We'll use a count if function. So if he's leaving in the state, we're going to count it. There's the range. Again, with this, we need to use the weird syntax. So we'll put these in quotation marks. Using and. Actually, we might not even do that since we're hard coding. Okay, so we'll use the same plan before, but instead of choosing a variable here, we'll just put in 50. It's greater than 50 counted, right? So we're looking at this from the view of Biden. And similarly, if Biden is not winning the state, then Trump will be the same. Is the different state. And you'll see as we refresh this, these values change, right? So each one is a different possibility. We can do the similar thing for the electoral college votes, which would give us sort of a top line answer as to who won. So there's 550 votes. Let's build a similar column to the second one here with the expected number of Biden votes. So again, in this case, each is equal to if this sample is greater than 50, as in if he wins the state, gets the electoral college votes, if not, it's none. We'll apply that to each row. And so now we can just sum all these up. Again, the difference is what Trump will get. Okay. So now what we have is we have a small model that every time we refresh it gives us a potential outcome. So in this outcome, Biden wins with 360 electoral votes. In this outcome, he wins with 361. In this outcome, he just barely wins by 289. And so we could sit here and just keep refreshing all day and try and get sort of the range in which these potential outcomes lie. What we're going to do is use a data table to host all of that information. It just makes it a whole lot easier. So data tables can be a little bit complicated. And so if it doesn't quite make sense, I would recommend, there are plenty of resources that I watched on YouTube to sort of get an understanding of how all it works, all the mechanics behind it. But right now, I'll just sort of show you what we can do. So we're going to create a table to host all of these values. Yeah, to listen. Okay,
yes, I was just wondering why some of the samples are negative. Like if they should be negative, kind of. Do you get what I mean?
Right. Yeah, I know what you mean. This just sort of comes on an error of time. It's because we hard coded in those values there. What you'll find is 0 and 100, the ones that we hard coded in, are far enough away that there's essentially no chance that this would not be a Democrat win, and essentially no chance that this will not be a Republican. In reality, we could probably hard code these values as well. So that these are 0, these are 100. It won't change the outcomes that we get, but we could clean it up. In reality, should it be a negative number? No, because the average we can have can only be between 0 and 100. But in this sense, if we had more time, I would sort of go through the process of cleaning that up. But from an outcomes perspective, it doesn't change the outcome.
Right, makes sense.
Yeah.
Thank you.
Tally?
What was the equation you used for states Biden leading? The one where you have the value of 30?
Right. So it's just counting up. It's using the countif function. So it's saying if the result from that sample has Biden leading the state, as in above 50, then count it. If not, then don't count it. That makes sense?
Yeah, I just missed what it was. Thanks.
Okay, sure. Okay. So let's create this table of all these different trials. And like I said, we're going to essentially run this model 1,000 times to consider all the different possible scenarios, or at least a good representation of different scenarios. So we'll just sort of list off the trial number. 1, 2, 3. Excel is very good at picking up on trends. So if you have data entered in like this, you can just sort of continue it on. And you see this number changes. It recognizes that it's a numbered list. It'll just sort of continue that along. So if you just drag this down to do 1,000. Okay. So now this sort of sets up the structure. This first value here, so the value next to that trial number will be the outcome there. So maybe let's measure this as Biden electoral college votes. So what we're going to have is a list of all different scenarios and the associated Biden outcome with each of those. So to use the data table to generate this, what we're going to do is we're going to highlight the whole table. Again, that's what I did to select all of that is I select the top 2 rows, held Control-Shift, and used the bottom arrow, and it just sort of selected everything from me. We are going to go into Data, What If Analysis, Data Table. For the row input cell, these trial numbers aren't being used in any calculation. They're just there to sort of keep things organized at the time. In that sense, we're going to leave that. For the column input cell, do is to refresh columns or refresh all of the formulas to generate an outcome. And what you saw me do before is I said you can go into a cell, just a random cell, go into the formula bar, and just hit enter and it'll refresh it. So what we can do is just for the column input cell, select a random empty cell. Hit OK. And so now what we'll see is this whole table populates with random samples calculated by this number. So for this one, it refreshes everything, finds this number, puts it here. Same thing for this. Refreshes everything, finds that number, and puts it here. So what we have here is a list of Biden outcomes for all of the different trials. Yeah, Ryan, you've got your hand up.
Yeah, can you please quickly just go over what you just did for this? I could not catch it.
Sure, sure. Yeah. That's okay. That's okay. So I'll do it on a smaller scale. So we'll just create a small table just to keep things organized. All these different trial numbers. Sorry to get this long because I've got a lot of calculations. So let's just do. What we're going to do is put the value that we want from each outcome in the first row. So in this case, we're looking at the Biden electoral college votes. I'm going to select this number, hit enter. And now what we're going to do to implement this data table for each trial, we'll highlight the whole data frame here. Go into data, what if analysis, data table. The row inputs, these trial numbers not being used in any of the calculations, they're just there for organization, so we can leave that blank. The column input cell, we just want to select any empty cell. So that'll help us refresh for each trial. Hit OK, and it'll populate with results from each trial. Does that make sense?
Yeah, that does. Thank you very much.
For sure, not wrong. Tulissa, I still see your hand up. Is that just lingering, or do you have something to follow?
Sorry, it was from the last question. You already answered. Thank you.
Yeah, no problem. No problem. Okay, now we're at the point where we've got a long list of outcomes. So let's just do some summary stats of this and sort of wrap up. Based on all of these outcomes, let's say that this is all potential outcomes. What we're going to say is in how many of these outcomes did Biden win? And how many of these outcomes did Trump win? Then we can calculate as percentage of outcomes and use that as an estimate of saying, okay, we know one of these outcomes will be in here, right? And so we can use that to estimate the probability that one of those candidates wins based on the outcome. So if that doesn't make sense, just follow sort of what I'm thinking. So to say Biden percent win. And so what we're going to do is again use a count if function. So we're going to say if Biden has above 269 electoral college votes, he's essentially won the electoral college. In which case he wins the election. So this will count the number of times that he gets above 269 votes. And then what we're going to do is we're going to say, okay, what's the percentage that happens versus all outcomes? So we know that there's 1,000 samples here. So we say out of 1,000 samples, out of 1,000 samples, Biden in this case wins about 96% of the time. So we can look at this and say, okay, based on the model that we made, we would expect Biden to have a 96% chance of winning this next election. We could do a similar thing for President Trump. What we'll find is just the inverse of whatever this relationship is. So in this case, you can just say all potential outcomes, the difference is this. So we can look at this and say, okay, there's still a chance based on this polling that Trump wins. Based on the model that we have, we estimate that to be about 3.2%. If we refresh all the calculations and run all this over, you'll see that these sort of change and move around a little bit, but they're generally within sort of a small range. We made a lot of assumptions with this model, and so there are some reasons to believe that this might be a little bit over-optimistic for Biden. What you'll see is if you compare it to some of those other professional models, they generally have Trump winning between 8% to 13%, which certainly is higher than what we've calculated here, but it's not ridiculously high. A difference of 10 percentage points makes a difference, particularly if you're using it for betting markets or something. But between all of these models, we could look at it and say, there still is a chance that Trump can win this, but it's not terribly high. And so in that case, we're not saying for sure that Biden will win. We're saying it's likely that he will win. Still could be surprised. We were surprised in 2016. We've still got 10 days. Things can change around. We can get another October surprise. Who knows? Lots of stuff can happen. But this sort of gives us a way to sort of frame those expectations in a bit more of a quantitative sense. And if we had more time, we could go back in and sort of flesh this model out a bit more. We could say, okay, don't include polls from a long time ago, only include new polls. We can look at this and change the way that our samples are created. There's a lot of stuff that we could do to sort of change this model and make it a bit more robust. What we would find is it wouldn't change the total outcome a whole lot because those professional models are really in depth and we can see that the outcomes are simple. One last thing, we did this for sort of top line win numbers. We could have done it for each state. We could say, let's say we want to look at Georgia again. We can say, In this case, instead of picking the number of final electoral college votes, we can say we don't want that. We want the outcome for Georgia. And so if we run a similar data table analysis, it would give us the same thing. Well, not the same thing, but sort of the same format, where for each sample, this is what the outcome looks like. And we could do a similar percentage here and say, about 50% of the time, Biden wins Georgia, about 50% of the time Trump wins Georgia. So in that sense, we could, again, quantify, yes, Georgia looks like a toss-up, and this is the percentage chance that we would give to each candidate winning that specific state. So there's a lot more that we could do here, but this sort of is a very broad overview. And I don't particularly feel like it would be worth expanding out any further right now. I know we spend a lot of time. So I'm probably going to leave it there. As I wrap up, are there any questions? Did this make sense? Was this helpful? I know we covered a lot, but I just want to make sure that it was useful. Because it was a bit more project based. Yeah, Ryan, go ahead.
Thanks so much. I don't have any questions, but this was really awesome. Thank you for taking us through this.
Cool. Like we said at the beginning, this is sort of being used to inform if we sort of look to explore similar workshops, maybe with other people or different topics. I think what we've seen is quite a few people logged on and stayed on. And so if you have any feedback or things that you might want to see in the future, please let Ray or I know. And so we'll keep that in as we sort of figure out what's going on in the future. Otherwise, I don't have anything more to add. So Ray, is that you saying that you don't have anything else to add either?
I have nothing to add either. I'll do my best to share this recording with you guys. Fingers crossed that everything works out technologically, but a huge thank you, Jake. And yeah, please reach out with any feedback, guys. And if ever there's something else that we can do, that'd be really, it'd be really fun. Thanks for joining.
And if any of you want to connect offline as well and maybe talk a little bit more in detail, feel free. I'm around. Happy to join you. But for that, I say enjoy the rest of your Saturday, and hopefully